Sea turtles are miraculous. First, they've been around since the late Jurassic, roughly 150 million years ago. Cohorts of the dinosaurs, sea turtles have survived through the challenges of eons, existing still today where many others have ended their evolutionary run. Second, throughout the centuries and up till today, every living adult sea turtle has overcome the odds, existing as a consequence of chance, skill, and capability.
Turtles are reptiles order that are neither mammals nor birds. As a description, they have scale and scutes instead of feather and fur. Turtle families house up to 400 species. They are found in different parts of the world such as land, freshwater, rivers and lakes, saltwater, sea and oceans. To recognize them, scientists have divided turtle orders into families and the later into species, depending on its location, shape and habits. On the other hand, saltwater or marine turtles is divided into two families, the Chelonidae family and Dermochili family. Chelonidae family embraces green turtles, flatback, hawksbill, loggerhead, Atlantic ridley, Camp ridley, and Pacific ridley. On the other hand, the Dermochili family includes only one type, which is leatherback sea turtle, which is in our case is the natural resource concept.
The answer lies in the peculiar way the bones develop. In most animals, including humans, the ribs grow by bending and tucking inside the shoulder blade. But in turtles, the shoulder blades are pushed further inside the body, allowing the ribs to grow around them. Meanwhile, the belly bones develop below. So that's how the arms and legs end up inside the shell. In hard-shell turtles, the ribs expand and fuse to form a solid bone box. But in the leatherback, the ribs remain unconnected and are covered in a soft, leathery skin. In most sea turtles, the lower shell is made up of 9 bones, which are fused together to form a solid plate. But in the leatherback, these bones are reduced to a ring around the edge. Filling in is this layer of fat, which not only covers the belly, but encircles the entire body. But what's it for? Large whales and turtles is surprised by her first impressions.
Think of a turtle shell as having bone all the way around. There's some bone right over here, but what's really amazing is this part is just fat. So a turtle shell made out of fat is very unusual. In fact, it looks a lot like a marine mammal because it seems to have a blubber layer.
In other animals, the food pipe leads directly from the mouth to the stomach. But in the leatherback, it takes a circuitous course around the stomach, making it 6 times longer than other sea turtles.
This is the inside of the esophagus, or the food pipe going from the mouth down.
The muscular wall, and then this insulating fat.
This long, spiky food pipe is the key to how this turtle can cope with its diet of jellyfish. For this giant, its feeding philosophy is quantity, not quality. To prevent its stomach filling with seawater, the food pipe acts as a temporary storage vat. When it fills, muscles squeeze the water out, whilst the finger-like papillae keep the jellies in, before they're then passed into the stomach. This unique adaptation allows the leatherback to eat its body weight in jellyfish in just 1 day.
So inside the head of the leatherback, you would expect to see primarily brain. But what you find is the brain was just in this little channel right in the middle, and the biggest things in the brain are the salt glands, which are effectively acting like kidneys.
Inspired from the leatherback sea turtle and the means of its survival, 4 design strategies can be applied. To begin with, the first design strategy is the seamless envelope of the building, the sheeting. Similar to the seamless thermal layer of fat that functions as a thermal insulation and having a lower freezing point temperature from other mammals, an enhanced seamless roof and wall sheeting will be in better insulation with a bigger lifespan. The current roof and wall sheeting is a composite panel that requires a lot of maintenance over the years with a lower design life. Therefore, it is more commercial than sustainable. Ziploc system, however, is an ideal solution for this equation. This system has a longer lifespan with the lack of any fixed penetration, thus avoiding air and water leakage. For the purpose of assessment and evaluation, we have used the Ecotact analysis to show a comparison between the current situation and the updated material. This graph, the first one, reflects the thermal analysis for passive gains breakdown, while on the other hand the other one, and after updating the material of the roofing and assigning Ziploc system instead, the results came significantly different. In particular, the reduction of passive gain through conduction that is revealed in red color. Strategy 2. The hydrophobic surface. As we have noticed, leatherback sea turtle has an oily leathery skin, giving it the effect of hydrophobe. By definition, hydrophobe means fear of water. Mainly, this phenomenon is derived from lotus effect. When exposed to water or liquid, water droplets roll gently over the leaves, removing all traces of contamination, giving it the character of self-cleaning. As droplets are formed on the leaves, a high contact angle between the surface of the leaf and the water is formed. The rounder it is, the more hydrophobic it is. The surface becomes super hydrophobe over 150-degree angle. Hydrophobic coating can be applied on components, textures, musical instruments, architectures, athletic products. When the formula is coated on a surface, it evaporates, forming a nanoparticle structure. This nanostructure makes water repel, forming a high contact angle. The surface of the spray coating is filled with nanoparticles that is filled with a rough surface. You think it is smooth, but it is actually not. Many suppliers over the web sell the product of super hydrophobic coating like Never Wet, Ultra Dry, and Belco Nano. To do the evaluation assessment, I will calculate the total area of the envelope of the building, summing up to 8,387 square meter. Assuming that 1 liter of super hydrophobic coating will cover up 70 square meter depending on the proficiency of the labor, price of 1 gallon is equal to $10. Total cost therefore will be $3,200 applied each 10 years, since the durability of this coating will reach up to 10 years. So therefore the total cost in 1 year is $320 only. Strategy 3. Heat exchange. Introducing heat recovery wheel. This strategy is inspired from the melanosomes organelles that are embedded in the epidermal skin of the turtle. The role of melanosomes is to store and absorb the daylight heat, regenerate it when needed. This function of regenerating the energy is called heat exchange. HRV or heat recovery wheels are usually installed in the air handling units. Depending on the surface structure of the wheel, it can increase the cross efficiency from 10 to 15%. This system utilizes the cold air intake extracted from the toilet, which is the blue color in the simulation, to cool down the fresh air intake dry bulb temperature, which is the red color. When the wheel rotates, heat exchange will take place, cooling down the surface of the wheel from the cool air, and then thereafter dry bulb temperature, the hot air, will reduce gradually. Throughout EcoTact analysis, I have applied thermal load calculation for current and updated situation, especially after installing the HRVs. It clearly reflects the total amount of load reduction required for both heating and cooling. Strategy 4. Improving indoor air quality. Introducing smoke vents. Similar to the internal esophagus spikes of the leatherback sea turtle that ejects the excess of water from the body of the turtle, smoke vents will function as much as the same, synchronizing the CO2 and heat sensors with the mechanism of the smoke ventilation will provide the optimal indoor air quality.